Right, I have made another movie, another example of Dijkstra's algorithm again. So because it's something you have to see a couple of times, and I will do also perhaps one more review. But this you can also think of this already a review for the quiz that is coming in shortly. So Dijkstra's algorithm, and we go again from S to start to end. It's very similar to the previous one, but the numbers are a little bit different. I hope a little bit more interesting things happen for you to see as we go along. Okay, so here we go. So we have we start with our S here, and we have our end at the end, although it's not necessary. Okay, and to show you, I'm going to put my E here, and then I get A, B, C, D, F, G, H, I, J, K, L, and M. All right. Okay, this is gonna right fit in there, and then we have. So these are the vertices, right? So here we're gonna see here. This will be the cost, and here will be the previous, right, the previous vertex. To where did I come from? The direction, if you want. Okay, so we initialize this. So we have two steps. So step 0 is initialization, like initialize. And that means everything has cost infinity except for the start. Let me give myself a little bit of space here. So everything else has infinite cost. Because I have the cost will be only changed if I updated it. Okay. So we start with the lowest, and then we have the two things we always do. Step 1, vertex of lowest cost, but it cannot be the endpoint, different from the endpoint. And step 2, inspect its neighbors plus update costs of these neighbors. I'm just saying very quick, very shortly, so that when we do it, you'll understand exactly what we're doing. Okay, so remember, what we do is, I'll try to keep my color straight. It's I start with S, okay? So, and I look at the neighbors of S, which I make green. The neighbors are A, B, and C. A, B, and C. I update their costs by just, there's nothing much going on here. There's a 7 here. For B, it's 2, and for C, it's 3. Okay, and I keep telling me this is coming from S. Okay, that's it. That takes care of this. The first calculation is done. In other words, S is taken care of. So I don't have any information anymore, and perhaps more importantly, I'll make it red there. Look at the one with the lowest cost. That is not the endpoint, but that is B in this case. Okay, so we take B. And we now gonna go. So this is what the greedy part is. I didn't explain it last time. The greedy part is take always the one that is cheapest, right? That's what you would think, right? You're sitting in the car and they say, and the GPS tells you, okay, go this way, that costs you this much, this way costs you this much. You say, okay, I take the one that costs me least, 2. And from there I'll probably get, I'm gonna keep it cheap that way. Okay. All right, so here we go. What are the neighbors of B? A, D, and G. Okay, A, D, and G. Let's quickly update. There's an update here because to go to B, that's the current cost at B is 2. Now I'm going to A, that adds another 3 to it. That will make the cost via B 5, which is better than what I have. So I'm changing this into B. Okay, that takes care of A, right? Let's do one at a time that I don't get. I'm sometimes a bit too quick. D. D is just definitely going to be better to go to from B. B costs 2, and then from B to D costs infinity, so that's going to be 6. All right. And what about G? If you're in B, it costs 2, and another 8. That's going to cost you 10 to go to G. Okay, 10. All right, we are done. Okay, and so B is also taken care of now. I can make this red. Okay, B is B. What's the cheapest one available? That is C. Okay, C is the cheapest one. So I take C. Here is where is C? Here is C. What are these neighbors? There's only one neighbor remaining. That is I. I. That cost is infinity, so definitely this is going to be better. What is the total cost to go to I? It's a total cost though. It's the cost to go to C plus the additional cost to go from C to I. That's altogether 5. Okay, that takes care of this neighbor, but then also that's nothing. Therefore, also C is done. And so, and I forgot to write again. I did it again. I keep forgetting to write. How did I get the cost of I reduced? Because I came from C. How did I forgot to do this? I'm so sorry about this. I don't know why I keep forgetting this. How did I get from D? That was from B, right? And G was also from B. This is very important. Okay. Please stop me if you see me forgetting this. Okay, there's no way you can do that, but okay. So what did I just finish? C, right? So C, C. What's the cheapest one available? A. Let's take A. Just let's go alphabetically. It doesn't matter. We saw that it doesn't matter anymore, so I'm not gonna. I take A. Here is A. What are your neighbors? A. Well, A has a couple of neighbors. The neighbors are D, F, and B already taken care of. So D and F. Okay. So let's see. Can I update D? D currently costs 6. But via A, it costs 5 plus the cost to go from A to D, which is 4. That is 9, right? So from A, it's 5, and then an additional 4 that costs 9 if you go that way. That's not better, so I'm not going to take that. That's, again, the greedy part. And so that takes care of that. So I don't do anything as far as D is concerned. So D, you're done. What about F? Oh, yeah, okay, sure. That's going to be better than infinity, right? My current cost at A is 5. The current cost is A is 5. Don't say, oh, there's 7. No. The current cost at A is 5. And there's a 3, cost 3 to go to F. So this altogether will be 8. And that is coming from A. Great. That takes care of this guy. So we are done with this one. So the next one now is, we're done with A, so let's get A out of the way. Okay, so here is A. So A and A. What's the next cheapest one? I. That's the, and still we cannot pick E, right? But at some point we will, but then we will say why we don't pick it. So we pick I, and I is here. What are your neighbors? I. Well, I says my neighbors are J and K. Well, C you took already care of. So J and K, fine. They're both going to be changed. This is going to be 5 to J plus an additional 6. That is going to be 11. And this is coming from I. And let's do K before I erase everything. K, it cost me 5 to go to I. And then from I to K is another 3. So altogether 8. And this is also coming from I. Great. So, sorry, let's get rid of all the colors now. I is done. Okay, let's mark I is done. I is done. I is done. What's the cheapest one available? D. Okay. I'm thinking, D is the one. I'm going to work with D. So D is the one that's going to bring me cheapest. So D, where is D? D is here. All right. Don't think too much of this as a physical locations, right? You might say, oh, you're far away from E. That really doesn't matter. This is not far. There's nothing to do with far. It has to do with cost. Okay, what are the neighbors of D? The neighbors of D are, well, B and A we already take. Oh, there's only one neighbor I have to look at. F. Okay, let's see. Can I do better at F? Oh, sorry. Can I do better at F? In D, to get to D, it cost me 6, and to go from D to F is another 5, so altogether 11. No, that's not better. Okay, so I don't do anything. Okay, that was a lot of steam for nothing. So D is done. D is done. What is the next one available? 8. Okay, F. Okay, F. All right, F. I'll inspect you. Where is F? 8. Okay. What are your neighbors? Well, there's only one neighbor left. That is G. So G. What does it cost to go from F to G? That's 3. But F itself already cost 8. So this part will cost me 11. That's not good. I'm not going to update it. So, all right. F, you didn't help me anything. Well, you didn't help me better. It might still be that F was the right way, but at the moment, I couldn't do better with F. Okay, so what's the next one left? K. All right, K. K, where is K? Here is K. Okay, what are your neighbors, K? The neighbors of K are J, O, what do I do? J and L. All right, let's calculate costs here. To go to J, okay, let's mark them, otherwise I forget it. So it's J and L, okay. To go to J, from K, that's cost me 8 to be in K, and then from K to J cost me another additional 1. Oh, that's better than what I have, because I have 11 here, and now it becomes 9. So no, so I'm going to come from K, not from I. So that's why I also have to update that, and I hope I keep doing this, otherwise I'm going to get stuck again. All right, so that's that. That takes care of J. What about L? Well, L definitely is going to be better, whatever way it had. From K to L is 6, and K itself cost 8 already, so altogether 14. Okay, and that is coming from K. Perfect. Okay, so we get rid of all this. We're done with this. We're done with K, so let's make K red now. K is red, K is out. What's the next cheapest one available? I still have 2 infinities, 3 infinities even. Okay, J. J is the next one that is available, the cheapest available. J, so J, all right, J, what are your neighbors? Well, he has only one neighbor that needs to be considered, that's L. Okay, so let's see, can I do better if I come from J? L costs currently 14. Now, J currently costs 9, and then coming from J to L costs me 4. Oh, that's better. That's 13 only. This is only going to cost 13 if I come from J. Perfect. Good, good. Thank you, J. You helped me. Okay, so that's it. It looks always good that I improve, right? Improvement seems always better. Well, we don't know yet, but that's at least, if I feel something is happening. Okay, J is done, J is done. What's the least available? 10, G. All right, so here is G, G. Where is G? G is there. What are your neighbors? There's only one neighbor to be considered. That is H. So H, oh, H definitely will need to be updated here. G had costs 10, right? Here, this is where I read what the cost of G is, and H is another 2, so altogether 12. So 12, and that is coming from G. Of course, there is no other way to come from to H than from G, but okay, that again, we don't look at these things. I could have, let me just for the, no, I cannot do that because I already did this. Oh, I haven't expected L yet. I'm gonna just, can I please? I haven't done it. Hope that you understand, just agree with me. This has not been in consideration yet, because I've never considered. The ones that I've considered are the red ones, and the current one is the orange one. So not this guy H and L. I've never looked at them yet. So okay, I'm done here. That's my point here. I added this one thing just for making it a little bit more juicy. Okay, so what I've done, G is done. All right, I'm talking too much, and then I lose track of what I'm doing. G is done, and see, I forgot to color this one. Okay, what do we have? Infinity 12 and 13. Well, another infinity here. Okay, I think 12 is the smallest, right? As far as I can remember, 12 is the smallest. So orange. So 12. Where is H? Here you are, H. What are your neighbors? I have now 2 neighbors because I made them one more. L and E. Finally E. But that's doesn't mean that I'm there, right? Just because I reached E doesn't mean that it was the best way to reach E. Okay, all right. So H, let's go E. Okay, E is easy because that's definitely going to be better. The current cost of H is 12, and the go-to there is another 3, so this will be 15, and this is coming from H. Good. And what about L? Okay, let's see. Can I do better? If I come from H, the current cost is 12, and another 12 is 24. No way, Jose. I'm not going to take that. So, okay. So, no, I'm not taking this. I'm done with all considering H. So, H is done as far as I'm concerned. So, H, you can go sleep. All right. What's the next one? I have an infinity still at 13 and 15. 15 seems to be the lowest one available. I forgot to color this one. So I'm going to take 13. L. Here is L. L has only one neighbor to consider anymore, that is M. So M, okay, oh, that's going to be definitely be improved, right? Because 13 plus an extra 2 to go from L to M, so this will be 15, and this is coming from L, okay. That's the only thing I can do with L, so again, things are going to go much faster now because there's not much left anymore, right? But we see we're really inspecting everything. So here is L, I did L is done. 15. Well, I cannot pick E, right? Remember, that's what it says. Take the lowest cost, not E. Okay, I have to take M here. So let's take M. Okay, where is M? I'm taking M, and its neighbor is E. That's, of course, there's nothing left anymore, so that's E. Oh, come on. E. Okay, can I improve if I come from M? Current cost is 15, plus 1 is 16. No, that's not shorter. So that doesn't change anything. This means M did not help me much. So I'm going to put M out. Pick the lowest vertex of lowest cost different from E. There is none anymore. So step 4 is, step 3 if you want, find the path. Because I have now found the cost. That's 15. How do we find a path? Find path by backtracking. So how did I get? And so this table, this column now tells me how did I get there. Okay, you got into E, and I'm going to do this up here because otherwise I'm getting. No, I have to keep the whole table in view. I have to squeeze it in somewhere. Okay, I'm going to put it here, right? We have seen the answers here already. We don't need to see this anymore. So here's my path, right? I end in E, so I'm going to write E last, and then to reach E, I came from H. So this is the H. So now we'll look in my table. Where is H? H. How did I get to H? The best way to come from H was G. So G. Now we'll look in my table from G. The best way was to come from B. Okay. How do I get to B? The best way from B was to come from S. So this was the path. So the path, the cheapest path was S, B, G, H, E. Okay. But you see, this one is a little bit more of recalculating, recalibrating, and I'll do another one in the review. You will see even a little bit more. Now, one thing perhaps very quickly, what's the complexity of this algorithm? So the complexity, and if you think about it, the worst case scenario is that you have a complete graph, that every edges have weights. So you have to, basically, you see, one thing you see, we have inspected every edge. So at least the first one of the loops, this loop here, that picks every edge, takes at least n steps, because there are n vertices, right? So complexity in terms of vertices, n the vertices. Now, for every vertex, I have to inspect all its neighbors. Now, I don't know how many neighbors there are, but worst case scenario could be as many as, well, not n by n minus 1 or n minus 2. So in the order of magnitude n. So the complexity, the worst case scenario complexity is O(n) squared. So it's a quadratic one, which is not great, but it's the best that we have at the moment. Okay.